Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Runita Rizkyanti Putri. Hari ini saya akan menjelaskan profil saya sebagai salah satu persyaratan untuk sertifikasi dosen. Saya sudah 9 tahun bekerja sebagai dosen di program studi Teknik Kimia Universitas Lintas Internasional Indonesia atau biasa dikenal sebagai IULI. Pada tahun ini saya telah memiliki jabatan akademik dosen lektor dan tahun 2025 ini saya telah diangkat sebagai Kepala Program Studi Teknik Kimia Universitas Lintas Internasional Indonesia. Pada kesempatan kali ini saya akan menjelaskan salah satu mata kuliah yang saya ampu di Universitas Lintas Internasional Indonesia, yaitu Chemical Engineering Plant Design atau biasa dikenal sebagai perancangan pabrik. Kelas perancangan pabrik merupakan mata kuliah wajib program studi yang dilaksanakan ketika mahasiswa berada di semester 6 dan merupakan mata kuliah dengan bobot 4 SKS. Mata kuliah perencanaan pabrik merupakan mata kuliah integratif yang bertujuan untuk membekali mahasiswa dengan kemampuan menerapkan seluruh pengetahuan dasar teknik kimia dalam perencanaan dan perencanaan fasilitas produksi dalam skala industri. Mahasiswa akan mempelajari dan mempraktikkan proses pengembangan desain pabrik secara menyeluruh, mulai dari penentuan spesifikasi produk, pemilihan proses, perhitungan teknis, hingga analisis teknis dan juga ekonomi. Seperti salah satu persyaratan wajib di Universitas Lintas Internasional Indonesia, mata kuliah perancangan pabrik diajarkan dalam bahasa Inggris dan ini termasuk dalam metode pembelajaran dan juga metode diskusi di kelas baik antara mahasiswa maupun antara mahasiswa dan juga dosen. Untuk mata kuliah perencanaan pabrik sendiri merupakan mata kuliah project class dalam bentuk berkelompok dengan tujuan membuat perancangan pabrik sesuai dengan kaidah teknik kimia. Bahan kajiannya terdapat 3 buah, yaitu kalkulasi teknik, proses, dan juga ekonomi. Untuk mata kuliah perencanaan pabrik sendiri terdiri dari 14 pertemuan ditambah 2 pertemuan, 1 yaitu merupakan untuk presentasi laporan tengah semester dan terakhir adalah mengenai presentasi laporan akhir semester. Mata kuliah perencanaan pabrik ini sendiri menggabungkan mata kuliah yang telah dipelajari sebelumnya seperti kesetimbangan massa, termodinamika, perpindahan massa, mekanika fluida, bahkan ekonomi teknik. Jadi mata kuliah ini menggabungkan apa yang telah dipelajari oleh mahasiswa sejak semester 1 sebagai mahasiswa teknik kimia dan kemudian bergabung menjadi satu mata kuliah besar, yaitu mata kuliah perencanaan pabrik. Dalam mata kuliah ini, mahasiswa diajak berpikir secara mandiri melalui proyek, di mana akan ada progress report setiap minggunya untuk mengetahui sejauh mana progres pengerjaan proyek baik individu maupun dalam grup. Penilaian pun dibagi menjadi 2, yaitu pertama adalah penilaian individu dan yang kedua adalah penilaian secara grup. Untuk penilaian secara individu itu dilihat menggunakan log sheet, jadi setiap grup harus mengumpulkan log sheet apa saja yang mereka kerjakan setiap minggu dan juga diskusi dalam grup itu akan menjadi nilai individu. Sedangkan untuk nilai kelompok itu berdasarkan laporan dan presentasi proyek, baik itu laporan tengah semester maupun laporan akhir semester. Dalam mata kuliah ini terdapat 12 subchapters dalam pengerjaannya yang berkesinambungan dan harus dikerjakan secara kontinu. Maksudnya apa? Maksudnya suatu chapter sebelumnya harus dikerjakan sebelum dapat melanjutkan kepada chapters berikutnya. Karena apabila chapter sebelumnya belum selesai, maka tidak bisa melakukan kalkulasi teknik untuk chapters berikutnya. Penggunaan aplikasi teknik seperti Microsoft Visio ataupun AutoCAD merupakan nilai tambah dari mata kuliah ini. Jadi selain penjelasan secara presensi di kelas maupun diskusi grup, mahasiswa juga dipaksa untuk mempelajari aplikasi-aplikasi teknik dalam pengerjaan proyeknya. Hasil laporan kemudian akan dicetak dan disimpan di perpustakaan. Hal ini akan menambah kebanggaan tersendiri terhadap mahasiswa karena itu merupakan hasil pengerjaan mereka yang dapat dilihat oleh junior-juniornya. Berdasarkan hasil proyek mahasiswa pada kelas ini, sudah beberapa jurnal yang saya terbitkan bersama dengan mahasiswa. Salah satunya adalah comparison of ethanol from durian, pineapples, and watermelon, dan juga differential of and cumulative particle size distribution analysis. Jadi jurnal-jurnal tersebut merupakan salah satu bagian dari ketika ingin mengerjakan project plan design yang kemudian dapat kami kembangkan menjadi jurnal yang diterbitkan pada jurnal terakreditasi Sinta. Adapun beberapa pengabdian yang dikerjakan baik secara kelompok maupun secara kelas berdasarkan kelas ini, yaitu seperti contohnya penyuluhan mengenai good manufacturing practice. Karena ini kelas mengenai perancangan pabrik, tentu saja kita belajar banyak mengenai good manufacturing practice dan penyuluhan tentang GMP baik ke UMK atau ke masyarakat sekitar merupakan salah satu contoh kegiatan pengabdian yang dapat dilakukan berdasarkan mata kuliah ini. Baik, sepertinya itu saja yang dapat saya jelaskan. Nanti setelah ini akan ada contoh penjelasan materi di kelas yang merupakan introduction to plan design, yaitu pertemuan pertama untuk kelas perancangan pabrik. Itu saja, terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, so good morning class. So welcome to semester 6. So today is your first day in semester 6 and guess what? You're going to do plan design. So what have you heard about this class? Have you heard about plan design maybe from your seniors, maybe from alumni? So today we are going to do an introduction to plan design. So I'm going to tell you what are you going to expect in the semesters, what you're going to do this semesters in this class. Okay? Next is regarding the evaluation. So because this is a project class, so you know that it will be different from any other class that we've already have. Okay, so if previously you have quizzes, you have assignments, and then you also have final examinations, but for this project, you have this component as you can see here. Can you see my slides clearly? Yes, okay. So first is the participation in the group discussions. Because this is a project class, so every time you do a project discussion or group discussion, I will see your participation in that group discussion. Alongside with that, your group mates will also send a report to me in any kind of form, maybe through WhatsApp, maybe through a report, log sheets, how active you are in group discussions. Next is the personal report. So at the end of the semester, you're going to submit the report as a group project. Yes, okay. But there will be one part in the group report. There will be a personal report, which is regarding the unit operation chapters, and that one will be inside your personal report, which is the portion is 10%. Next is the midterm report and presentation, which is 10%. So we have 14 weeks, around 11 or 12 chapters throughout the project. So by the end of week 7 or week 8, you're going to submit a midterm report and then you're going to do a midterm presentation. So I will know how far you've gone to your project. So I don't want you to stumble upon at the end because you haven't finished any of your midterm report. And then next is the final report and final presentation. So by week 14, you're going to do final report and you're going to also do the final presentation with half a portion of 30% and also 20%. So the difference is that in this class, we will not have any final examinations. Yes, because it is a project class. Yes, of course. So that is why you're not going to have any final examination. You're going to do the final presentation and also final report. Okay. So anyone have questions up until here? Or maybe you want to have a final presentation and a final exam as well? No? Okay, let's continue then. Okay, so what to expect? So here in our class, there will be 4 SKS, means it is 4 hours meetings per week. And what we are going to do is, will be 1 hour, I will do a general explanations about the subtopics. So as I mentioned earlier, we will have 14 weeks of meetings. There will be around 11 to 12 sub-chapters. And then each week, I will be explaining to you the subtopics for this week. And what I want you to understand is that the topics will be a continual topic. What does it mean? It means that you need to finish the previous week topics before you can continue to the next one. Okay, so remember, before we continue to this week's chapters, it means you need to finish up with last week's chapters. Okay? And then after I explain about the subtopics of the week, then I will give you 2 hours of a group discussion in class. And then you're going to do 1 hour of a progress report. What have you discussed in class this week? Okay. And during the progress report or during the group discussion, we can also discuss previous chapters. Maybe there are some things that you haven't understand or you haven't finished up. You can do that as well. Okay. Any question so far? Maybe someone at the back? No? Okay. Right. So next is log sheet. So this is how I know or how I understand how active you are in a group discussion. Because maybe the 4 hours in class is not enough. So maybe you will need half time to do somewhere in Starbucks or in a cafe to do this project. It's okay. What I need you to do is I need you to fill up this log sheet. So each group will need to submit the log sheet at the end of the report, and then you need to put the date here. So when do you do the discussion and who active participate in that discussion here, and also what is the subtopic covered, and I will sign each week when we meet in class. Okay. Right. So next one is a timeline. Because this is a group project, so there will be a timeline, and I want you to understand. Because as I previously mentioned, that the project or the sub-chapters will be connected with each other. Let's say you need to do the energy balance part. So this is the mass balance. In week 5, you need to do energy balance, right? So you need to finish up the mass balance first before you can continue with energy balance. Because if you haven't finished the mass balance, you cannot do the energy balance, like the one that you did during the, I don't know, second semester, if I'm not mistaken, right? Okay, so the first week, which is today, what we are going to do is we are going to do the introduction to plan design, and also the most important part, which is the project determination. So later today, after I explain everything, what I want you to do is I want you to create a group, maybe 4 or 5 person each group, and I want you to discuss what kind of project that you want to do during this class. Okay, so later maybe I will give you like hints what I expected for you to do. Maybe I can also give you an example from your seniors or from your alumni, what kind of projects that they do in the plan design. Okay, and then next week, what you're going to do is the forecasting or market. So because at the end of the day, what you want to know is not only determine the project, and you need to know where do you want to sell your product, and then how much you want to produce in a year, let's say, and then what is the forecasted product for 20 years later. Because when you build a plan, you don't only think for 2 years, 5 years. You need to think about 10 years, 12 years in advance. Okay. Next is the root process and also Kepner trigonometrics. So in here, in the third week, you're going to determine how you're going to create your product. So you're going to think about the process design. You're going to think about what kind of raw materials, what kind of equipments, things like that. You're going to determine using a root process. So you need to read a lot of journals that stated how to create the product that you want to produce. Okay, and then using a Kepner trigonometrics. Have you ever heard about Kepner trigonometrics? Maybe somewhere at the back? No? Well, yes, because Kepler trigonometric usually used in a business and social science faculty. But we are here in the chemical engineering department. We also use a Kepler trigonometric. So a Kepler trigonometrics is basically a way for a system to show us which one or which root process is the best for your product. So let's say you have 4 different root process. Using a Kepler trigonometrics, they will show which one from the 4 root process is the best for you. Next is, in the 4th week, we are going to do a block diagram and also mass balance. So do you still remember about block diagram? Or maybe the difference? So block diagram versus process flow diagram. Yes, this one is a PFD. Yes, thank you for still remembering that. So do you still remember what is the difference between block diagram and process flow diagram? So block diagram means that we regard the process as a block. So we don't think if it is heating, if it is mixing, if it is packaging, we don't regard that. We only regard this as a block. So we can see something like this. Remember, always put the numbers on your streams, right? So 2, 3, 4, 5, and I always put a number also in the process as well. So this is what we call as a block diagram. Hope you still remember this. So in the block diagram, we don't really regard what is this process. It can be mixing, it can be heating. We don't really regard that. Okay. And then in the process block diagram, this is what we call as an IPO system. Do you still remember what is an IPO system? Yes, IPO system. Yes, that is correct. IPO means input, process, output system. Why? Because here, only using a block diagram, you can know which one is the input, which one is the output, and which one is the process. How? By using this streams. So that is why you need to use arrows, because the arrow shows which material or which energy going in or going out from our system. Okay? And what is the difference with the PFD? So PFD is an advanced version of a block diagram. What does it mean? It means that it is using a specific unit or a specific symbol that shows us what kind of equipment that we use. Let's say, this first part is a mixing, and let's say this one is a heating. If it is in block diagram, we don't really regard that. We just draw it as a block. But here in the process flow diagram, we already use what kind of mixing equipment that we use. So do you remember the type of mixing equipment there is? We have batch mixing, we have continuous mixing. Anything else? Continuous stir tank reactor, yes. Plug flow mixing, yes. Anything else? Right, so we have, let's say, if I have a CSTR, so continuous stirred tank reactor over here, which is a CSTR. So I already need to use the exact symbol for the CSTR. And also, let's say the heating, let's say I'm using oven. So this is the exact symbol for oven, let's say. Oh. Don't forget to always give numbers to your flow. So this is exactly the same process, but have 2 different functions. Here in the block diagram, we only want to know what is going in and going out. But here in the process flow diagram, it already showed what kind of equipment do you use. And why is it important? Because as a chemical engineers, we don't work alone, especially when we design a plant. We will work with electrical engineers, we will work with mechanical engineers, and the PFD, the process flow diagram, is how we communicate, how we understand each other. So this is like a language specially made only for an engineers. And then After you create the block diagram, you also need to calculate the mass balance, right? And then next is energy balance. After you finish up with the energy balance, you need to calculate the energy balance, and then you will have time during this week 6 to do a group discussion. Before in the week 7, you're going to do a midterm report and also a midterm presentations. And then during week 8, after midterm presentation, you're going to do fluid mechanics. So do you still remember what do you learn in fluid mechanics? Yes, you're going to calculate the pipes, you're going to calculate the pumps, you're going to determine the pipe types, to determine the velocity of liquid inside of a pipe. Yes, that's correct. Thank you. Next is the PNID, piping and instrumental diagram. So piping and instrumental diagram is a diagram that is more advanced than the process flow diagram, that it will show all the instrument that you're going to use inside of your plant. Both safety instrument or even instrument that you need to use to ensure that your design is correct. Next, in the week 10, you're going to do plan location and floor plan. So this is where you're going to determine where do you want to build your plan, how big your plan will be, and then how many workers that you're going to use, how many supervisors, how many operators, let's say. And then week 11 is going to be plant safety. So you're going to determine how safe it is your plant to operate. You're going to use HACCP. If you still remember, what is HACCP? Yes, it's hazard and operation. So you're going to do a qualitative safety analysis method for this. And then week 12, you're going to do engineering economy. So you just have engineering economy last semester, if I'm not mistaken, right? So I'm sure you can do that. So why? Because at the end of the day, if you have state of the art equipment, if you want to create a very unique product, but if it is not going to give you profit, then there will be no investors going to invest in your plant. And of course, that is not our goal. And then in week 13, you're going to have a group discussion and final report submission. And then during our last week, you're going to do a final presentation. And then at the final presentation, there will be not only me, so I will ask for other lecturers as well. I will ask the dean maybe, or I will ask other lecturers to come sit and give comments on your design. Any question so far? No? Okay, so plan design. What is plan design? Plan design is planning, designing, specifying, installing, modifying, maintaining plant facility system and equipment. What does it mean? So when we design a plant, we just don't design it. We think about how to install an equipment, how to maintain the plant facilities. And that is the job of the chemical engineers. Okay, so here in the plant design, there are two types of projects, greenfield and brownfield. Do you know what is the difference? Can somebody tell me? No? Anyone at the back? No? Okay, so greenfield means that there is a client, let's say, come to us and then they will ask, can you create a plant? And then we have nothing. Means that they just bought a land, or maybe um, they just think about creating a product. So this is what we call a greenfield. While brownfield means that when there is a client or when there is a company that they already have a plant running and they want to expand their plant. Maybe they want to add more warehouse. Maybe they want to add more operation line. Maybe they want to add laboratorium, let's say. So this is what we call as a brownfield project. Okay, my next question will be, which one do you think will be easier, greenfield or brownfield? Yes? Okay, so of course it is, each one will have their own pros and cons, because in greenfields, you will have a lot of um, possibility to do. You can have a small plant, you can have a big plant, you can have small equipment, large equipment. You can build a soccer field, let's say, in your plant. Is entirely up to you as the designer, yes. But because we have so many possibilities, somehow it is very hard to determine what kind of plant that we want to do. While if it is in brownfield, of course, the cons will be there will be so many restricted areas. So you cannot stop the plan that is already running to stop for you to build another line, right? So you need to work along the timeline. So maybe you need to do it like 2 a.m., 3 a.m. in the morning, things like that. But of course, it is a smaller scale in comparison to the greenfield project. Okay, so this is the 5 steps in designing a real plant. Okay, so here, can you see? So first is a conceptual design, or we call it a CD, and then basic design, which we call it a BD, and then detail design, a DD, and then a construction, and last one is validation and commissioning. So what is the difference between CD, BD, DD, construction, and validation and commissioning? Anyone know? Anyone have ever built a plant before? Okay, so CD is a conceptual design. So this is where this project will be headed. Okay, so in this class, I will expect you to only create a CD. So CD is already a whole engineering calculation is already put in there. So you already determine what kind of product, mass balance, fluids, layout, blah, 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 everything is already there. But the difference is that usually is the percentage of error allowed. If it is in CD, the percentage of error allowed is usually around 30%. And then once it's finished with CD, we are going to go to BD, means that more and more engineers will work on that, and then the percentage of error allowed will down into 20%, goes into DD, and DD, the allowed percentage of error will down to 10%. After that, it's going to do a construction, so the building construction, and then last one is validation and commissioning. So the whole time, usually the time needed to build an actual plan is roughly 3 to 4 years. So it's not like one night or one day type of project. Of course, it is not. So CD or conceptual design usually around 4 to 6 months, which is the perfect time for you to do the project in class. Okay, any question so far? Right, so maybe my last 2 slides. So here in the plan design, so why is it important? Because plan design is a very specific subject that we as a chemical engineers can do. So in the whole wide world, the one that can do a plan design is only us, chemical engineers. So you should be proud on that. Okay, so what is that? Because in plan design, you're going to correlate everything that you've already learned in the past 3 years, from your first semester up to your 6 semesters. You're going to use your knowledge in unit operations. You're going to use your knowledge in material balance, energy balance, fluid mechanics, engineering economy. Everything will be put together inside this class, which is plan design. I always remember back in my days, I don't know, a decade ago when I was a bachelor degree student, I always think, why do I want to learn chemical engineering? Or why should I learn mass balance? Why should I learn energy balance? But I find the answer here in the plan design class, because everything makes sense now. Everything that I've already learned previously is being used into this one class. And why? Because plan design is $1 million knowledge. Clients will pay you a lot of money if you can do this. Okay, so I expect greatness from all of you guys here. Okay, good luck.